In this video, we will look at transfer learning, one of the strategies used for training deep neural networks when the number of data points available for training for the particular task that you are interested in is very low. So, the idea here is to use what we can refer to as a pre-trained model. Okay. So for instance, let us say you have some data wherein you are trying to figure out for a particular task. Okay, it's not an ImageNet challenge. For instance, you are trying to determine a species of birds, or easier still, you have a limited number of data to determine the make or the make and model of a car depending from the pictures. Let us say this is some hypothetical task, but then you do not have enough data, maybe you have thousands of data points, but that is not sufficient for training a deep neural network. So, what you would do is you would take a network like AlexNet or VGG or Inception, which has been trained on ImageNet database. Do a forward pass through the pre-trained network, so forward pass the data, right, and store the embedding. So, if in the case of AlexNet or VGG, you have about 4096 neurons in the output layer before the classification layer. You take this as a representation of your data. So, now your input data is now represented by 4096 length feature vector. So, that is a feature that represents your data, and you use this as input to another machine learning framework, let us say an SVM, support vector machine, or binary trees, or maybe just another neural network that you can train with this data and classify it appropriately. Okay. So, this is a strategy that works very well, that is taking the embedding. In this case, this 4096 D vector would be the embedding that you get from your CNN. So, this strategy works very well if the task at hand, if the data for the task at hand or the task at hand is similar to something that the ImageNet accomplishes. In this case, since we are talking about ImageNet, we will take that as the standard. So, ImageNet networks, the networks trained on ImageNet data, pretty much it's a classification network or image recognition network. It is trained on thousands of types of images, okay, and you can safely assume that it has learnt all kinds of possible features, okay, corresponding to the images from the wild present in the ImageNet database. Now, if your input data is very similar, in our case, example I quoted that type and make and model of the car, or let us say even type of species of birds, or for instance species of cats or dogs. Okay. That data is kind of similar to ImageNet data. So, if you have a network trained on ImageNet data, maybe then you can use this 4096D representation as a reduced representation of your input data, and then use another machine learning paradigm to train it in order to accomplish your task. However, in some cases the data might not exactly be the same, or maybe you probably have a slightly larger data set. In that case, what you can do is you can take the network with pre-trained weights, okay, modify the classification layers from 1000 neurons to the number of classes in your new data set that your task demands, and then train the network. So, this portion of training the network is basically training the network with whatever data you have for your task, and this process is this training with your excess data is referred to as fine tuning. Okay. And in general, this is what people refer to as transfer learning. Okay. So, you start with a network that has been trained on a very large database, and most often than not that image database is very similar, or the task to be accomplished is very similar to the task that you are now proposing to do with your current deep CNN, and then you use your limited data set to modify the weights in your network appropriately by using a backprop, and this typically works very well in many cases. So, the reason it works, as I stated earlier, is that if you have a fairly large database which is labeled just like the ImageNet database, okay, considerable effort has gone into making that. So, and if you have a network trained on it, couple of things. One is that given the size of the database and the depth of the network you are trained on, safe to assume that the network has learned all kinds of low level features which are transferable to other tasks. So, here the deeper layers, let us say for some CNN trained on ImageNet, the deeper layers learn task specific features. So, for instance, speeches specific to a certain breed of dog or cat. These are easier to train as these are closer to the classification layer. So, the errors back propagate faster. The initial layers learn more generic low level features like edges, blobs, some kind of patterns in the picture, and generally difficult to train because of the errors being difficult to backprop the errors from the output layer to the innermost layers. So, if you have a network which is trained on a fairly large database on a task which is kind of very similar, closer to what you are, or at least related to what you are going to do, then it is safe to assume that at least that the low level features learned by that network are transferable to your task. Okay. So, we just try to exploit that features learned by this already trained pre-trained network for your task, and since the deeper layers are easier to train compared to the innermost layers, the earlier layers in the network, fine tuning the data your network pre-trained network with the data that you have will hopefully modify your outermost layers and adapt it to the task at hand. So, so in general, when we try to do this transfer learning, one strategy is to freeze the initial layers, because as I mentioned earlier, you would expect that the low level features are also transferable to your data. In some cases, it is possible that even you are using the pre-trained network because you feel that you can say that the weights have been initialized to a pretty good value after training with that large database, but then your task or your input data is totally not related to the network you are using. So, for example, for the second case, let us say you are trying to accomplish a radiologic task. We will look at a case study later on. So, you are trying to classify chest X-ray scans, right. Right. So, we are looking at chest X-ray scans as being abnormal or normal. Okay. Now, this data, chest X-ray scan data, is not similar to ImageNet data at all. It is quite drastically different, but then you would still like to exploit, the deep network that has been initialized with pre-trained weights, but then in this case you would have to necessarily train from scratch. Okay. So, but in that case the assumption is that you have enough data to do so, and this is another mode of transfer learning, even though you use the pre-trained network as a good initialization of weights, and you would still go ahead and train all the weights in all the layers using the data available to you. So, just to illustrate some of the points that we have talked about earlier. So, ideally, if you have data which is, let us say, similar to, in this case since I am looking at here, this is AlexNet, okay, we looked at this before. So, your data is similar to ImageNet, and then you have a classification or recognition task, right. Then what you would do is you would just drop this out, okay, and then replace it by, say in this case, let us say you want looking at 10 breeds of dogs, instead of 1000 you will have 10 output, and then train or fine tune with whatever data that you have for the task. Okay. But then let us say your input is radiology data, chest X-ray. So, dissimilar but large data. So, you take the, of course, you would modify, still go ahead and modify the output layer. Let us say you need only normal versus abnormal. So, instead of 10 you will have just one output, right, you can say 0 or 1, and you would train the entire network. This is assuming that you have radically different data, but then you have enough of it. So, because there are, if you know, AlexNet has several million parameters, 60 million, and if you want to train them you need to have as many data sets. Of course, you also do data augmentation in order to increase the size of your data set artificially. So, given that the data is dissimilar on the tasks of chest X-ray is a good example, or medical data in general, medical imaging data in general, or some form of spectral data which is not similar to ImageNet, then you would have to train the network from scratch, but you can use the pre-trained network, the pre-trained weights as a good initialization. Okay. So, that is typically this is recommended. So, in any case, even for in any case, if you have enough data, let us say you have hundreds of tens of millions of data points, let us say images for instance, for some particular task, one thing you can still do is to keep the network architecture, retain network architecture. In this case I have shown network, but you feel that you want to use inception or some other model, that is fine, but you train from scratch. So, that way you have you do have a structure, a CNN architecture that has been proven to work with large data sets, image data sets. So, you can use that same architecture, even try to see if some of the training hyperparameters can be applicable or not, and use your data to train it from scratch. Only if in the case where you have dissimilar data, but you do not have enough of it. Okay. So, in the sense that it is not millions, but maybe you have several thousands, and then you can do data augmentation, maybe you have tens of thousands. Then you still, the idea would be to freeze some of these layers, okay, and also that is to train the final layers. Let us say maybe train these few layers using your data and hope for the best. Okay. The assumption behind freezing these layers is that that at least you believe that the local features, the low level features learned are transferable to your task that you are interested in. So, all these strategies put together typically is learned referred to as transfer learning, wherein you to put it in simple terms, you take a pre-trained network and see if you can just modify it slightly to accomplish your task of interest. Okay. So, the other scenario that I think I alluded to earlier on is when your data is actually very similar to, let us say in this case you are looking at AlexNet trained on ImageNet data, maybe you have a very similar data since let us say you are looking at cat breeds or dog breeds, you want to identify different type of dog breeds based on just the picture. You can just then, as we discussed earlier, just take this embedding out and put it through let us say another neural network, and you have either 10 outputs, 100 dog breeds let us say, or 10 dog breeds. Okay. Such a thing is possible. Okay. So, if it is very similar, then you do not have to maybe even train from scratch or try even do a fine tuning. You can take the embedding from the network. Okay. This is done in many cases. So, for instance, if you are trying to do tasks like video segmentation, video frame segmentation, or trying to do object detection, then many of the inputs look like the objects in your inputs look like objects in, let us say, ImageNet. Then you can use ImageNet directly in such the sense the networks trained on ImageNet directly in such applications. Okay. When you move across applications, then you will be careful about how you are going to accomplish transfer learning.